All right, now we're going to start 12.3, which is about ellipses. So ellipses are what we generally think of as oval shaped. They can be this direction or this direction. The first thing we're going to learn about is how to find the constant sum of an ellipse. So an ellipse has a set of points in a plane such that the sum of distances from any point P on the ellipse to two fixed points, F1 and F2, are called the foci. There's two of them, so it's foci. The singular would be a focus. And that is given by this constant sum equation. Okay, and then what can we use to find the constant sum of the ellipse? We are going to use the distance formula, and I'm going to show you how to do that. So basically what this means is you are finding the distance between some point P and the first focus, and then the distance between P and then the second focus. So if you look at here how we set this up, it says find the constant sum for an ellipse with foci F1 at 3, 0 and F2 at 24, 0, and the point on the ellipse at 9, 8. So we have this equation where we're using the distance formula, and we are finding the distance between the point P and then F1 and then the point P and F2. So if you notice here, both of these have x3, y3 in them, and that is going to be our point. So this is the x3, the y3, the 9 and the 8, because that's in both of them. Okay, so the F1 is going to be our x1, y1, and then our F2 is going to be our x2, y2. Okay, and you can always use this as your x3, y3. Okay, so now we are going to substitute. So x1 is 3 minus 9 squared plus y1, which is 0, minus 8 squared. And then plus our x2 is 24 minus 9 is our x sub 3. Our y2 is 0 minus y sub 3, which is 8. And now we can do our calculations. Okay, so we know 3 minus 9 is going to be negative 6. Negative 6 squared is 36. Negative 8 squared is 64. We know that that's 100. The square root is 10. We're not done yet. We do have to add it over here. 24 minus 9. We know is 15. 15 squared plus 8 squared, which is 64. 15 squared is 225. 225 plus 64 is 289, which is a perfect square at 17. 10 plus 17 is going to be 27. And so this is the constant sum. All right, and now we're going to learn a little bit more about the parts of the ellipse, and then we will learn how to graph them. So with this, I am going to do the parts. Okay, so instead of a single radius, an ellipse has two different axes. Okay, the longer axis is called the major axis, and it passes through both foci. The endpoints of the major axis are called the vertices of the ellipse. Okay, the shorter axis is called the minor axis. And then the endpoints of the minor axis are called the covertices. of the ellipse. The major and the minor axis, they are perpendicular and they intersect in the center of the ellipse. When you have an ellipse that's centered at 0, 0, it depends on whether you have a major horizontal or a major vertical axis. And so we're going to look at these two forms in the diagram below. So notice the major axis is whichever one is longer. So in this case, the vertical one's longer. So this is the major, this is the minor. For horizontal, this would be the major, this would be the minor. And then you have the co-vertices on the minor, the vertices on the major. Okay? And then you have the focus, which is labeled on your major axis. And then you have the standard form for your equation. And then you can see different variables are assigned to the vertices, the foci, and the co-vertices. Another important equation that is not on here is that the values of A, B, and C, they are related by this equation, which looks similar to the Pythagorean theorem, but it is a little bit different. It's C squared equals A squared minus B squared. Okay, and then also note that the length of the major axis is 2A, so 2 times your A variable. The length of the minor axis is 2B, and A will always be greater than B because A is always with the major axis, which is going to be longer. All right, and then we are going to do example 2 in the next video.